Off the coast of northwest Greenland, the water is perfectly still, but puddling on icebergs indicate a transformation is underway.
Scientists scanning Greenland's ice detected something none of them had ever seen before.
Scientists have drilled ice cores through the layers as far down as they can get, and then they analyze those layers.
Buried deep under the frozen surface was a massive, perfectly shaped sphere with no natural explanation. The moment their instruments locked onto it, the object began releasing timed pulses.
Right now, we're going to go put a probe right where that little yellow dot is. 3, 2, 1, drop, drop, drop.
These signals did not match any known geological pattern. They were controlled, they were deliberate, and they came from inside the sphere. Something beneath Greenland was not silent. It was active. The silent vault at the edge of the world. The first major hint that Greenland was hiding something extraordinary did not come from satellites or modern scanners. It came from a drilling project in 1966. During a military research mission, scientists pierced through nearly a mile of ice and pulled up samples they expected to be nothing more than frozen sediment. What they found instead shocked the entire team. The samples contained leaves and pieces of wood that still held their structure. When the researchers added water, the fragments expanded and unfolded as if they had been frozen only days earlier. Nothing this old should have remained in such perfect condition, yet the ice had preserved it completely. This discovery changed how scientists viewed Greenland. It proved that the island was not just a frozen surface. It was a sealed world capable of protecting anything hidden beneath it with almost impossible precision. The ice functions like a natural vault. Once something becomes trapped under its weight, it remains untouched by decay, weather, or time. According to several research teams, anything buried deep enough can survive for hundreds of thousands of years without losing its shape.
Camp Century held up as an heroic conquest of the Arctic in the never-ending pursuit of scientific progress.
Greenland itself remains one of the most isolated regions on Earth. Nearly the entire island is covered by an ice sheet that reaches close to 2 miles in thickness. The surface appears quiet, but the ice beneath it holds dense layers formed over countless generations. Each winter adds a new layer of snow, which slowly compresses into clear ice. The deeper the scientists drill, the older the material becomes. These layers hold trapped air, dust, and traces of ancient events. They provide evidence that Greenland has remained frozen long enough to store entire chapters of Earth's history. Very few people live on the island. Most settlements sit along the coast, leaving the interior untouched. There are no roads leading into the frozen center. The land remains empty, open, and largely unexplored. This isolation adds to the sense that Greenland is hiding something beneath its frozen surface. No one has walked across most of the interior. No one has seen what rests miles below. Beneath the ice, the environment grows even stranger. Heat rises from inside the earth and warms parts of the bedrock. This creates pockets of meltwater that move quietly under the surface. These pockets are difficult to study directly, but they prove that Greenland is not a simple block of frozen land. It has hidden layers, tunnels, and ancient materials that remain out of sight. The preserved plant fragments from 1966 were only the beginning. They revealed that Greenland once supported life, but what researchers discover next goes far beyond old forests or forgotten landscapes. What they uncover is an entire unseen continent buried under the ice. The continent no one has witnessed. When scientists began mapping Greenland's interior with modern imaging systems, they expected to find simple bedrock and old glacial scars. Instead, the first detailed scans revealed something entirely different. Beneath the ice sheet was a vast hidden continent shaped by valleys, sharp ridges, and enormous basins. These landscapes were not small features. They stretched across regions that had never been seen by any human being. The discovery stunned many of the researchers because it meant that Greenland's real geography had remained secret for thousands of years. One of the most surprising findings came later, when deeper mapping revealed a canyon longer than the Grand Canyon. The Grand Canyon is already one of the largest natural cuts on Earth, yet the buried Greenland Canyon stretches even farther and remains perfectly preserved under billions of tons of frozen weight. This discovery suggested that ancient rivers or floods had once cut through the rock with tremendous force.
That's when Scott Pelley went north to the Greenland ice shelf to witness a global warning. the melting Arctic.
The canyon's depth and length indicated that Greenland had been shaped by violent geological events long before the planet entered its current ice age. The idea that such a massive formation had been sitting in complete darkness shocked even the most experienced geologists on the team. Another discovery came from a wide basin buried under the central part of the ice sheet. It was a dried lake bed filled with untouched layers of sediment. These layers revealed that the lake had once gathered water from many directions, which means the land around it was covered with flowing streams and active waterways. This single lake bed showed researchers that Greenland had once been a living landscape with running water, not the frozen world it is today. As these discoveries piled up, scientists started to grasp a larger truth. The Greenland known today is only the surface. The real Greenland lies hidden 2 miles beneath the ice. Not a single person in recorded history has seen its mountains, valleys, or former lakes with their own eyes. Everything that makes up this secret continent has remained locked away since long before humanity developed written history. During the mapping process, unusual shapes began appearing on some of the scans. They did not match the natural flow of valleys or mountain ridges. Instead, they appeared as straight paths and nearly circular bends. Some of these shapes repeated themselves across separate scans. Reports from a few early technicians suggested that the shapes looked engineered rather than natural. These reports were treated carefully, but they were not ignored. They created tension in the research camp because no one wanted to assume something extraordinary without proof. The presence of these strange shapes pushed the scientists to carry out deeper and more targeted mapping. They concentrated on the areas where the odd features appeared most clearly. The deep ice that breaks every rule. When the research teams pushed their scans deeper, they expected to see tightly packed layers of ice arranged in simple, predictable patterns. Instead, the data revealed enormous twisted structures that did not match anything known in glacial science. These formations rose upward through the deep ice in large, curling shapes. Their size immediately confused the researchers because they were far taller than normal ice formations.
This part of Greenland is melting faster than just about any other. And to get a sense of the enormity of what's happening, consider this.
The lower layers should have been fully compressed, but these shapes showed that something was disrupting the way the ice usually forms. No one could explain why it was happening. As the teams reviewed the scans, the irregular shapes stood out immediately. Natural ice flow usually creates smooth curves that follow the pressure of the glacier. These structures did the opposite. They bent in sharp and unpredictable ways. Some curled inward, some leaned sideways, some seemed to twist as if pushed from an unusual angle. This behavior did not match any known movement of ice under heavy pressure. The researchers checked their instruments several times to make sure the data was accurate. Every test confirmed the same disturbing shapes. The radar beams added another layer of confusion. Whenever the radar passed near these twisted formations, the signals bent and returned with strange echoes. The echoes were difficult to interpret because they did not follow a clear pattern. Technicians struggled to make sense of the distorted readings. At first, they suspected equipment malfunction. However, when the same problem occurred with different machines in different locations, the possibility of faulty equipment was dismissed. Something in the ice was affecting the radar, and it was not doing so by accident. Identical formations began appearing in separate regions of the ice sheet. This discovery removed any doubt that the structures were random. Their presence in multiple areas suggested that a wider force was shaping them. Some internal notes from field researchers stated that the formations looked as if they were influenced by something beneath them, although these statements were speculative and not confirmed. Still, the idea unsettled many members of the team. It implied that whatever was affecting the ice might be located deeper than their scanners could easily reach. Pressure readings added more concerns. Instruments detected concentrated pockets of stress around the twisted ice pillars. These pockets did not spread outward as expected. Instead, they pointed downward in narrow channels. It was as if the ice was reacting to a heavy mass below it. This discovery raised more questions than answers. If there was something beneath the pillars, then it was large enough to alter the pressure of the surrounding ice. These signs convinced the researchers that they needed to investigate further. The distortions were too consistent to ignore, and the idea of an unknown force beneath the ice created a sense of urgency in the project. The team decided to send their instruments deeper into the meltwater channels. They needed to understand what was hiding below the formations, and the meltwater paths were the only available route. Descent into the meltwater tunnels. The anomalies in the deep ice forced researchers to go beyond surface scans. To understand what had been affecting the ice from below, the teams began studying the meltwater systems that ran under the sheet. These meltwater channels were narrow, unstable, and extremely cold, yet they provided the only direct pathway into the deeper layers. When the first thermal maps came in, they showed a maze of twisting passages carved by water that had been trapped under the ice for long periods. These pathways were unpredictable and changed direction in ways that surprised even experienced glaciologists. The team prepared reinforced cables and lowered their first set of sensors into one of the wider tunnels. The descent was slow, and tension rose as the instruments dropped farther than expected. The first camera feed revealed icy walls closing in tightly around the equipment. The water inside the tunnel was dark and constantly moving, which caused the camera to sway. As the probe traveled downward, the water pressure rose sharply. This sudden increase caused the equipment to shake violently, and the technicians worried the cable might snap. The shaking stopped as quickly as it began, leaving the team unsure about what had caused it. A second camera was lowered into a nearby tunnel to collect clearer images. It moved through thick sediment that clouded the entire feed. The sediment grew heavier and eventually trapped the probe. The operators attempted to pull it free, but the tension climbed too high. If they continued, the cable would snap and the probe would be lost. The team remotely detached the device. Losing the probe frustrated the researchers because the equipment was expensive, but it also raised concern. The sediment should not have been that dense in that part of the tunnel system. As the teams regrouped and reviewed the data, they noticed something else. The instruments had recorded vibrations that did not match normal meltwater movement. These vibrations were rhythmic and steady. They traveled upward from a deeper section of the tunnel. This detail made several members uneasy. Meltwater did not create timed vibrations. Something else was producing them. Temperature sensors revealed another unexpected detail. Instead of dropping with depth, the temperature rose slightly the farther the probes descended. This suggested that heat was coming from an unknown source beneath the tunnels. According to speculative interpretations from a few researchers, the warmth possibly indicated geological activity, but no volcanic activity had ever been recorded in that area. The lack of any known explanation troubled the entire team. A third probe was sent deeper than the others. The descent went smoothly until it reached a new section of the tunnel. Without warning, the camera jerked, and the audio picked up a clear, sharp sound. The sound was metallic and unmistakable. The probe had struck something solid. The room went silent as the team replayed the audio. Ice and rock did not produce that kind of tone. The researchers mapped the probe's exact coordinates and compared them with previous readings. Everything pointed to a large structure sitting beneath the meltwater channel. The discovery created a sense of urgency. The researchers now understood that the twisted ice formations above were not caused by random movement. Something solid and massive was buried deep below. The team knew they could not rely on camera feeds alone. They needed a direct approach to confirm what the probe had hit. With the discovery of a solid mass beneath the meltwater tunnels, the researchers decided to drill directly toward the anomaly to identify the structure. A hidden shape in the ice. The decision to drill toward the anomaly brought a mix of excitement and tension to the research camp. Everyone knew the deep ice had already shown signs of strange behavior, and now they were preparing to make direct contact with whatever lay far below. A controlled borehole drill was positioned over the mapped coordinates. The descent began slowly. The drill cut through layers of ice that had not been touched for thousands of years. The process took hours. When the drill finally reached the expected depth, the operators prepared for contact with rock or dense sediment. Instead, they heard a sudden change in the sound of the feed. The drill tip struck something smooth and solid. The operators froze. Ice did not sound like that. Bedrock did not sound like that. The sound was clean and even, as if the drill had touched a curved surface. The team pulled the drill back carefully and lowered a specialized camera through the borehole. The camera had been built to withstand extreme cold and high pressure. As it descended, the feed showed only tight frozen space around the lens. When it reached the bottom and turned toward the contact point, the room went silent. The screen displayed a reflective surface that clearly did not belong to any natural feature. It shined under the camera light with a smoothness the researchers had never seen beneath glacial ice. Even the slightest movement of the camera sent a controlled glare across the surface. Several team members reacted out loud. They understood immediately that the object was not natural. To confirm what they were seeing, the camera was pulled up slightly and lowered again at a different angle. The same curve appeared. The team repeated the test several times. Every angle produced the exact same result. This confirmed that the object was spherical. Calculations showed that it extended for several kilometers in all directions. The size left the team stunned. No known natural formation matched it. The next step was to take a material sample. A specialized sampling tool was lowered into the borehole and pressed firmly against the surface. It did not dent, scratch, or shift. More pressure was applied, but nothing changed. The sphere remained completely solid under every test. The researchers grew frustrated because no known sampling equipment could penetrate it. The refusal of the surface to react showed that the object was far denser than any natural material found in the region. Detailed measurements around the borehole revealed another surprise. The ice layers curved slightly around the sphere, suggesting it had been sitting in place for a very long time. The ice had formed around it instead of forcing it aside. A few researchers quietly suggested that the sphere might predate the ice sheet itself, but they marked this as speculation, since nothing could yet confirm it. The team reviewed all the data and tried to make sense of what they had uncovered. They had found something smooth, massive, and perfectly shaped. It showed no erosion, no damage, and no natural explanation. It rested deep in the ice, as if it had always been there. The discovery created a mix of fear and excitement. No one knew what the sphere was made of, or how it had arrived beneath Greenland. The camp grew uneasy because everyone sensed that this was only the beginning. Hours after the drill made contact, the first signs of activity appeared in the monitoring equipment, and the real shock began. First contact with the signals. The research camp had settled into its quiet late evening routine when one of the seismic monitors began to register something unfamiliar. The technician on duty leaned closer to the screen, expecting random tremors or background noise. Instead, he saw a pulse. It was faint, but it returned again after the exact same length of time. Natural tremors never behaved with this level of precision. He reset the system and ran a diagnostic. The pulse returned a third time, exactly on schedule. When he checked the location of the signal, the reading pointed directly to the center of the sphere. The technician called the senior geophysicist, who reviewed the feed with growing concern. They activated a secondary monitor to rule out error. The second monitor displayed the exact same pulse. The team gathered around the screens as the signal repeated again and again. Each pulse rose and fell with perfect timing. Several members exchanged uneasy glances. They understood that a geological source could not generate a pattern like this. The atmosphere in the monitoring tent grew tense as they realized the signal was coming from inside the object they had touched for the first time only hours earlier. Minutes later, the electromagnetic sensors picked up low-frequency bursts that matched the seismic pulses with complete accuracy. Every seismic pulse had a corresponding electromagnetic burst. The synchronization shocked the team. No known natural phenomenon linked vibrations in the ground with electromagnetic activity this precisely. One researcher whispered that the sphere might be active, but others urged caution. Even so, the tension rose as the signals continued without shifting from their pattern. The intensity began to grow slowly. The pulses remained controlled, but each one was stronger than the last. The researchers watched the lines on their monitors climb higher. They adjusted their instruments to prevent overload. When they modified the radar frequency, something unexpected happened. The sphere responded. It released a faster sequence of pulses. The change happened instantly. Everyone in the room fell silent. The idea that the sphere might be reacting to them caused visible worry. Some stepped back from the screens. The pulses began to spread outward from the sphere. Stations many kilometers away reported unusual readings and contacted the main camp for clarification. They asked if new machinery had been brought in. When they learned the signals were coming from beneath the ice, the distant teams fell silent. Multiple sites recorded the same timed pulses. Nothing like this had ever been documented in glacial research. Soon, several research computers began to malfunction. Data streams froze or collapsed. Files that had been stable earlier in the day became corrupted without warning. Technicians attempted to restart the systems, but several devices displayed errors they had never seen before. The interference spread through the network and affected both seismic and electromagnetic equipment. There was no explanation for the sudden failures other than the increasing strength of the pulses. Every attempt to trace the signals led back to the center of the sphere. The team ran several models, and none provided a natural explanation. There was no known power source inside the object. There was no geological pressure that could create synchronized electromagnetic patterns. A few researchers quietly admitted they feared the sphere might contain a mechanism that had remained dormant until now. Internal reports suggested that parts of the pulse data contained repeating structures, almost like fragments of a pattern. Some scientists believed this might indicate encoded information, though others warned that the data was too unstable to draw conclusions. Even so, the possibility unsettled the entire team. Repeating sequences did not appear in natural pulses. The camp became a place of confusion and rising fear. Equipment shook lightly during each pulse. Lights flickered. Communication devices cut in and out. The signals grew more erratic until the strongest pulse yet hit the entire site, triggering alarms across the camp. Then, just as suddenly as it had begun, everything stopped. The monitors went silent. Every sensor that had been picking up the pulses went flat. The electromagnetic activity vanished. The seismic vibrations dropped to zero. The abrupt silence unnerved the camp more than the signals ever had. The researchers waited for another pulse, another vibration, anything at all, but the sphere remained completely still. The leadership team called for a full system reboot to make sure nothing had failed. Even after every instrument was rechecked and recalibrated, the result remained the same. The sphere had gone silent again. But this time the silence felt deliberate. No one knew whether the object had shut down, or whether it had simply entered a state they did not understand. The uncertainty forced the researchers to reconsider the entire situation. The sphere was no longer reacting, no longer pulsing, no longer revealing anything. It was simply waiting, and that uncertainty raised the most dangerous question of the entire mission. If the sphere was not going to reveal anything from below, should they attempt to bring it to the surface? The attempt that changed everything. Arguments broke out across the camp as different researchers pushed for different decisions. Some insisted the sphere needed to be brought to the surface for proper examination. They believed the signals were a reaction to the drilling, and that keeping it underground was too dangerous. Others argued that tampering with it again could trigger another event. The leadership team called an emergency meeting to settle the debate. In the end, they voted to attempt a controlled extraction. The plan called for a reinforced winch system brought in from another research station. It was one of the few machines strong enough to attempt lifting an object of unknown size and density. The equipment arrived the next day. Crews worked through the cold to anchor the machinery around the borehole. The goal was simple on paper: secure the sphere with heavy cables and pull it upward in slow, steady movements. When the extraction began, everything seemed normal. The cables tightened, and the machine pulled with full force. For a moment, nothing happened. Then the sphere shifted. The sensors detecting its position confirmed it had moved slightly. The team felt a wave of relief. They believed they had made progress. That relief lasted only seconds. Without warning, the ground beneath the borehole shook harder than anything the camp had felt before. The machine strained as the sphere resisted the pull. A sharp sound came from below, like metal under extreme pressure. Before anyone could react, a violent burst shot upward through the borehole. The force threw equipment against the ground. A thick green vapor rushed out of the opening, spreading in a fast-moving cloud. Researchers stumbled back in shock. The vapor had a sharp chemical smell that irritated their eyes and skin almost instantly. Protective masks were rushed out as alarms went off across the camp. Samples of the vapor were collected and rushed to the lab. Minutes later, the first results came in. The vapor was acidic. Prolonged exposure could cause severe burns. The extraction had triggered a defensive response, or something similar to it. The team shut down the extraction immediately. The borehole was sealed with heavy equipment. No one argued after that. The risk was too high. If the sphere could release something that dangerous without warning, any further disturbance could be catastrophic. The camp leadership ordered the site closed until a larger international panel could decide what to do next. As the team evacuated, one question spread quietly through the group. It was not spoken in official reports, but every researcher carried it in their mind. If the world had the chance to bring the sphere to the surface again, should it be attempted? If you enjoyed this investigation, make sure to like this video and subscribe to the channel so you never miss our next deep exploration.